Everybody, Mr. Adamson here. Today's lesson we're going to talk about acids and bases and what they are, how you identify them, and the process you go through that. So an acid is a compound that dissolves in water to form a solution with a pH lower than 7. A base is a compound that dissolves in water to form a solution with a pH greater than 7. And the pH measurement indicates how acidic or basic a substance is. And recall that pH is a measure of the number of hydrogen ions in a solution. And as we get going and we talk about naming acids and bases and identifying, we'll specifically talk where the hydrogen comes into play. Now, here is a pH scale, and you can see there's many examples along that, 14 being the most basic solution, 0 being the most acidic solution. So if you look at 7, the number 7 here being neutral, and you can see some of the examples along the way. Whereas, human blood being acidic, and if we go all the way down to battery acid, okay, being very, very acidic, being at 1. And that's why you don't really want to get battery acid on you, because it's going to burn right through your skin. Now, acids and bases are in the food we eat and in the products we use. They are essential components of your biochemistry. So example, saliva is basic, so our teeth won't dissolve away. So if our teeth are really sitting in the saliva in our mouth all day, you don't want them to rot out of your mouth and fall out. So they're basic, so they're there to help clean, but they're not going to rot away your teeth. Now your stomach makes hydrochloric acid, which activates pepsin, which works in the breakdown of proteins into amino acids, so the proteins within your food. Now sodium hydrogen carbonate deactivates pepsin, so it won't eat away your intestines, and this is a basic solution, so it's neutralizing the acid. Now NaHCO3, which is hydrogen carbonate, or sodium hydrogen carbonate, sorry, then goes into your bloodstream to act as a buffer. Now, a buffer is a substance that keeps the pH of a solution nearly constant despite the addition of a small amount of acid or base. So as we're getting different nutrients and compounds coming into our blood from the food we eat and different substances we're exposed to, this sodium hydrogen carbonate stays in our blood to be a buffer solution. Now, your sense of taste helps you in sorting our acids and bases. Now, there's 4 forms of taste, and they are sweet, sour, salty, and bitter. And the Latin word acidus means sour. Now, acids and bases also feel differently, such as bases are slippery, such as soap. And there's just a picture of your tongue right now where you have these different taste components on your tongue. So seeing back towards the edge of your tongue in the very back there, you have bitter. So if you're eating something kind of bitter, that's where you get a bit of that dry mouth. Sour being on the sides, salty being towards the front, and sweet being right at the very beginning. Now, acids react with almost all metals. Most bases do not react with metals. And the easiest way to determine whether a substance is an acid or a base is by determining its pH. And this is where indicators come into play. Now, acid-base indicators are chemicals that are used to determine if a solution is an acid or base. Indicators change color depending on the pH of a solution. And litmus indicator is a chemical derived from a lichen, a plant-like organism, or a werewolf, for any of those who have watched the movies Underworld. And I'm just joking there, that's not true. It's a plant-like organism. However, litmus is usually used in paper format though. Now, blue litmus turns red when in an acid, and in a base it stays blue. Red litmus stays red when in an acid, and in a base it turns blue. And in a neutral solution, such as pure water, litmus paper does not change color at all. So what we just learned from those above statements is that red means acid, blue means base. Now, a universal indicator. A universal indicator is a mixture of several indicators that change color as the acidity changes. So, meaning it can go through the whole pH scale. Whereas litmus paper we were talking about before, from 0 to 6.9 really, that's going to be red, meaning you have an acid. And from 7.1 to 14 on the pH scale, it's going to turn blue, meaning you have a base. Whereas a universal indicator, there's a whole lot of color changes that can occur. And there's a picture of a universal indicator with all the different color changes as you go through the spectrum of the pH scale. Now, pH scale is a measure of acidity, so most solutions are between 0 and 14. Neutral solution has a pH of 7 at 25 degrees Celsius. Acid substances are below a pH of 7, bases have a pH higher than 7, and every increase of 1 on the pH scale indicates an increase of 10 in how basic a substance is. Now, a decrease in 1 on the pH scale indicates a 10 times increase in acidity. And just to kind of put it all together with a few of the properties, here's a table for you. So with taste, acids are usually sour, bases are bitter, touch, acids not slippery, bases slippery. Reactions with metals, well, acids pretty much react with almost all metals, whereas bases don't. Litmus indicator, we have red for acid, blue for base. Electrical conductivity, acids for the most part are conductive, bases for the most part are not conductive. And the pH of a solution is less than 7 for an acid, higher than 7 for a base. So everything we talked about, you can kind of refer to this table and gives you all summed up. And that's it, just on the properties of acids and bases and some of the ideas and how you identify them. Hope you're able to take a bit from that today. Thanks a lot.